Right, so let's have a look at the second part of the Malware and Network Analysis Lab. So our main focus is really to understand the network traces that we see in terms of our malware analysis. So for this part of the lab, hopefully you've restored your snapshot and you've also powered it off. And so for the next part we'll download a trace. So it's up to you how you set this up. Either use your pfSense firewall and get your DMZ hosts online, such as Windows 2003 or your Kali instance, or you can do it on your desktop if you want, if you have Wireshark. Or what I'm going to do is I'm going to mount my USB stick onto the Kali instance. So that this, I'm doing it this way so that you can actually see how to do this if you have to. Okay, so I'm going to download the zip file with the Pcap file in it. So what I'm going to do now is I'm going to insert my USB stick. Okay, so there it's there. And then I'm going to put the USB stick, the file, onto the USB stick. Now what I'm going to do is open up Kali. There it's there. And then this little button here, just let me quit that. This little button here allows me to mount the USB device onto my Kali machine. Okay, so it's a good way to be able to transfer your files back and forward between the virtual machines. If you've done any results or captured any traffic, then you can do it like this. Okay, so it just takes a little minute for it to actually mount onto the machine, but we'll get there. Still spinning there. Okay, so for this part of it, what this trace shows is the actual trace when the malware connects to the network. So we'll actually see what it actually does there. Okay, so it's just set up. Oh, sorry, here, and then here. That's fine. Right, so now we'll actually connect to our virtual machine. So it's leaving our desktop, and then it's now going to be mounted onto our Kali machine. Okay, so it should just get in a little minute. And there it's there. Okay, lovely. And there's our file. So we can just drag that onto the desktop. Shouldn't be too big a file. It's already there, so let's just skip that. Okay, then what we'll do is we'll just start Wireshark. Okay. And then we'll just get that added. Right then, so let's do some forensics analysis on this. Okay, so if we just trace through, we can actually see, and there is the signs there of our host trying to connect to the gateway. So you can see the ARPs there. So it's not getting connected at all. It's just trying to find, and it's doing a broadcast into the Windows domain for that domain name. So it doesn't get connected. But then what you'll find is that later on it does, when we connect the network adapter. Here we see it does a DHCP request. Okay, so it finds the DHCP server. It then so this is on there's the DHCP. Okay, there's that. So this is a DNS query for dq.fjpark.com on port 53, and it returns the DHCP server, returns back this IP address. Okay, so it's found the DHCP server here, it's found the DNS server, sorry, a DNS server here, and it's made the request, and it comes back with this IP address. Once it's done that, then it does a SYN, and it's doing a SYN here to a certain destination port. In this case, the destination port is 8800. So let's see what it actually gives us. And what it is that it's actually contacting a Yahoo mail server, and this is it saying hello to the server to be able to get connected to it. Okay, so to read the questions, then the basic signs really are of it trying to find out domain lookup, and then it actually manages to find the DNS here. And then it makes the SYN connection here. This is the first sign of it actually connecting to the email server. And there's the sign here of it first connecting to the controller, or the back end of the malware. So what it's trying to do is that it tries to contact the email server, and then actually it's trying to spam from there. Okay, so you can actually follow the trace from there. So you can actually see that in this case the email message hasn't been allowed to be sent. Okay. So how could we create a detector? Well, certainly we would detect when the malware was contacting the DNS server for the dq.fjpark.com. So we would detect that. We could also detect this IP address here and a connection, and would certainly be able to detect the connection to that IP address on port 8800. Then we might be able to detect the SNMP connection here. So this is connecting to the SNMP port, which is port 25. So we might be able to sense a connection to the Yahoo port on port 25, and then we could look at part of the message that's actually sent and see if we could detect that too. Okay, so now what we'll do is we'll actually see if we can detect our little piece of malware using Snort. Okay, so what I'll do is I'll just insert a Pcap file into the home folder. Okay, there it's there. Okay, so first thing I'll do is I'll create my rule. And go back to the lab, and we'll just make a copy. of this file. So with the newer version of Snort, you've got to include these configuration rules at the start there to do with the streams that are actually involved. So we should be able to open that one up, and hopefully we should be able to copy and paste into the virtual machine, if that's working, and it is. Okay, so we're alerting on UDP to port 53 for FJ Park, and we're going to write a message for that. So we'll just exit. Yes. Okay, so let's go ahead and it's Snort. Let's see for the rules file -R, so we can run Snort offline with our Pcap file just to test it, and then we'll create a log folder. So we may have to create that in a little minute. Okay, we do have to do it. So let's make a directory called log. Okay, let's try again. Great. And beautiful. There you go. It's detected 3 alerts there. So everything is looking really good. So let's have a look at our log folder, and there we are. And that's it there. Okay, so you can see there's the 3 connections that it made to the DNS server on port 53. Okay, so the next thing we want to do is to be able to detect the email message. So we can just do I'll just do a very simple version of it. Okay, so just alert, and then it's TCP this time, and there, and this time we'll do port 25. Content, let's go for if I can find, I'll just put that in just now, and we'll go back and check what the actual message was. And you've got to give each one a unique ID. So let's have a look at the message again. Just to see if we can tighten up on the basic signature of what we're looking at. Okay, just move that on. So let's load it. Yep. Okay, so we can very quickly go to our email message with port 25 then. So what we could do is that we could detect the Yahoo address there. So the Yahoo address is 98. Let's take a copy. So it's 98.136.216.25 as our destination, and we're sending a SYN on port 25. So let's just go for that one. Let's not bother with the content. So that's port 25, and we'll just detect when there is a call there. Okay, 98.136.126.25. It's fine. Okay, so let's do that again. see? Perfect. 9 alerts now. So we'll just give that a try. And now we have 9 alerts. And here are all our emails. Okay, this is all the SNMTP emails. So we can now go ahead and set up the address for fjpark.com from the trace. Okay, so fjpark.com is up here. There we are. Okay, so it's 217.23.2.159. That's TCP any there. So 217.2.2.156. It's a D of 113. Message. DQ. Okay, obviously what you can do is you can copy the rules back onto your USB device if you've actually done it that way. So, there we go. So, good, we've got a little error. So let's fix it in real time, just to show how to fix the error. Okay, so I've forgotten about the port that's involved. Okay, so I'll just put an NA there. And what we can do is we can actually define a flag here if you want. You can define the SYN flag, but we'll just go for any connection there. Okay, there it does it, and it hasn't alerted us on that. So let's actually have a look. It's triggered on the email. So what we'll do is we'll just have a look at what a rule looks like. Okay, so we just check that we've got that right. From there, 217.23.2.159. Oops. So there you go. This is how oops. I just put it to the background. And it's Control X there. This time it's hopefully going to be correct. Yay, 26. Yeah, that's good. Obviously it's going to trigger too much, so we would put in a SYN flag detector there to be able to see that. Okay, so there is our connections there. There's the extra ones that we've actually added. Again, need to change the message. We're also seeing the flags that are coming through here. So there's the flags that we get. Okay, so for the NetBIOS one, you can actually just find the port for NetBIOS. So I think that happened up here somewhere. There was a request. Yeah. Okay, so you're looking for port 137 for that one. So 137 with fjpark, and that one should work for you. Okay, so that's showing you like a simple example of our logs. Right, so let's look at the third part of the lab. So with this one we're going to analyse some Android exploits, and the first one is a reverse TCP connection, so that we can actually analyse to see Metasploit being installed onto a machine and then creating a reversed connection back to a device. Okay, so we'll do the same thing as we did in the last part. What I'll do is I'll download my Pcap file. I'm going to put in a USB stick. I'm just going to load it onto there, like that. Okay, it's not a very big file there. Okay, so if you wanted, we could go on to the Kali machine, as I've shown you before. Then what you do is that you go to here, open up your Kali machine. Then you just mount your USB stick onto it. But what I'll do is I'll just get it set up on my machine here, because there's no need for Kali in this case. So this actually shows a reverse TCP connection. So what happens is that the host at 172.16.121.170 dial back into this machine here. Okay, so you can see the connection actually happening. If you follow the stream, we can actually see this is what the remote TCP connection does. There is the shell created. So the red is from the attacked machine, and blue is what the intruder actually types into the types into the shell that's actually been created. Okay, so the TCP port used for the dial back, we'll just have a look. So that should be the destination port. 4445 is the dial back. And what's the IP address which hosts the malware? Well, that's at this address here, 192.168.0.24, and which is the IP address of the which is the IP address that hosts the malware, is this address here, 172.16.121.170, because that's the dial back. Okay, and the address of the attacker is 192.168.0.24. Okay, so this is the machine that's been attacked, and this is the dial back. This is the machine that gets dial backed to. Okay, so if we follow the stream, what we see is that all the intruder did was do a dir, and we can see the actual files actually on the machine. That's at 172.16.121.170. So now let's look at the next piece of malware, and it's this one here. So again, you could go into your Kali machine and put it onto a USB stick, mount it onto the Kali machine, but we'll just analyse it on my desktop here. Okay, so in this case, again we have our dial back. Remember, we need a dial back because we're behind NAT. So in this case, this is the machine that's doing the dial back, so that's the machine that's been attacked. This is the machine which is doing the attacking. And what we can do is actually follow the stream, and what we actually see is the interpreter is actually installed onto the machine. So this is actually loading onto it. eventually we'll actually see some commands actually coming through from the attacking machine. You can see here's the